Hello and welcome back. In today's video, we're going to go ahead and complete the electrical rules check for the register schematic, associate the components with reference numbers, and then also associate the integrated circuits with their footprints. Hi, my name is Adam. I'm building a 16-bit computer from scratch. I hope you'll join me on this journey. The first thing, let's start by creating all the symbol references here. That's done up here, and I want to go ahead and annotate everything, and that's complete. And what you'll see here is if I zoom in on this IC, you'll see that there is a U number now associated with each of these ICs, and if I jump over here, I'm going to stop doing that. Come down here to the capacitors. Each of the capacitors have numbers now associated with them, and even though I don't display them, even the resistors have a value associated with it or a reference associated with it, as well as the diodes, the light emitting diodes. So those have references associated with them. I'll save that work. The next thing I want to do is I want to run the electrical rules check. So we'll run that and just see how many errors I end up with. And only 4. I'm actually quite shocked by only 4. Input power pin not driven by any input power, so that's here. If I zoom in, oh, I'm sorry, over here, the ground. So for some reason it's not picking this up as being connected to ground over here. Not sure why. If I come back to my error check, same thing with this over here. It's not picking up that it's connected to VCC. Again, I'm not sure why. And then I've got capacitor. Capacitor's not connected, so for whatever reason, this never got properly connected to the power rails. So if I rerun that error check now, I should be down to just the 2, which I now need to go figure out exactly why that's giving me a problem, as I do not understand why it would. So the KiCad documentation shows this exact error, and again it indicates that the power pins are not driven by any output power pins, very similar to what we're seeing. That's the exact error message for both the VCC and ground nets. And apparently it's a common error. And to overcome this error, it states that there are special power flag symbols in the power symbol library. They're used to solve the problem by telling KiCad that the nets are actually driven. So let's figure out how to find that, and let's figure out how to add that and where to add that. Now my problem is on this and this, but I'm wondering if I don't add those flags here on my connector. So let's see if I can, what I can identify here. So if I put a power flag here, and I put one here, does that solve my problem? So I'll rerun, I'll delete my markers and rerun the error, and that does solve my problem. I'm frankly quite surprised that it took so little to actually get this working properly, to where it passed all of my all of the checks and everything. I was not expecting that. So I will save it once again. I will rerun and no violations. I'm shocked. I was not expecting it to come out this clean. And I did run through my sanity checks of checking and counting ICs and things like that, and everything else looks to be good. So let's start by assigning some footprints to the components that are in the schematic here. And I'll do that by running this footprint assignment tool. When that comes up, it takes a second, but it populates in all of the different components. And I'm going to scroll down here to the ICs. Now I've got a number of 74 AHC541 ICs. And I'm going to be using the SOIC footprint for those. Okay, 74 AHC541. And if I go to the bottom of the data sheet, zoom out a little bit, the other out. So this is a dual inline package. Let's roll down one more page here. Here's the SOIC. And if I look at the size of the width of the IC here, 7.5, and that's in millimeters. And if I look at the length of it here, 12.8. Now, how am I coming up with that? I'm looking at the two numbers. The one on top is max, the one on the bottom is minimum. Average the two of them, those should be 7.5. Same thing with up here. 13.0 should be maximum, 12.6 should be minimum, and average the two, so the midpoint is 12.8. And then my pitch up here is 1.27 millimeters. That's the distance between each of the pins. So that's the footprint I need to match if I'm going to use this IC. So I'm going to roll down here and look for package SO. And SOIC, I need a 20 wide, 7.5 by 12.8 millimeters pitch, 1.27 millimeters. That's the one I'm looking for. There's another 20 wide down here that's 15.4 millimeters. That's the incorrect footprint for that particular IC. So if I select it, whoops, and I didn't do that right. So let's try that again. Obviously, I've not done this before. I did a little bit of pre-research to make sure that I was actually selecting the right thing, and I had things available to me properly. So double-clicking that selects that. And so I've got several of these 541s, so I'm going to go through and try to select them all. And all of these are the 20 wide, 7.5 by 12.8. Now, I also have, let's close my data sheet. Next one down on the list is the 74HC193. Now recall, I was not able to find an AHC version of that, so I'm going to tempt fate and go for the HC193. Alright, so the 74HC193 is really the CD74HC182, which is part of two different counters here. So the 74HC193 is included in that. So let's go again to where the physical characteristics are. SOP. I'm looking to make sure that I have I don't want the TSSOP. So this should be 5.3, and it is a 16 pin, so it should be 10.2, and the pitch is 1.27. So once again, 5.3, 16 pins, so it should be, that is 10.2, and then again the pitch is 1.27. So let's go find that. Package SO, 16 pin, 16, 10.3, 7.5, 1.27. Go back to my data sheet. 5.3, 10.3, 5.3, 10.2. That's the one I want. Well, before I do that, let's go make sure that's the one I'm going to be able to get. That's the least expensive, and I have plenty in stock. 3.9 millimeter width. Wait, no, I wanted the 29 megahertz, not the 24 megahertz. Let's try that again. Again, 91 cents, 3.9 millimeter width. So if I go back here, that looks like the right one. Let's take a look at the data sheet for it. Am I looking at the right mounting? Yep, all surface mount. They're all 3.9 millimeter. Notice you have to make sure you buy the right thing. This looks like. So this is 9.9 in length and 3.9 in width. This is a 3.9 millimeter width. So what was I looking at here? I was looking at these numbers, 9.9 in length and 3.9 in width. So that then puts me at 9.9 millimeters by 3.9 millimeters. Pitch is 1.27. Pitch is 1.27. So that is the correct footprint to assign there. That's what I'm going to be able to purchase from my supplier. Now, you'll notice I went to DigiKey. DigiKey is not a sponsor, in full disclosure. All right, the 74 AHC 138. Active surface mount, SOIC, and show me what's in stock. I can get those in cut tape. These are 3.9 millimeter width. .16 pin. So these are the same footprints here. All right, let's double check and make sure I didn't do something stupid with the 541s width of 7.5 millimeters. So that is 7.5 millimeters. So that's good. So the 574 now. Fussy, 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 fussy. Let's take a look here. This is the DW package. So SN being the vendor or manufacturer, 74 is the series, AHC is the architecture of the circuitry, 574 is the actual IC function, and DW is the package. Alright, so the DW package is SOIC 12.83 is the width. Coming back here, whoops, coming back here, 12.83. So that it's actually accurate. 7.5 we confirmed from the vendor, 12.8 we confirmed from the datasheet. So I'm going to leave the video there in the interest of time. I do have the association of the passives complete, and I just need to edit that up and get that released. And then I also need to add some female connectors for testing. I want to be able to probe and test some of these connections on the register, at the register itself. So I do want to change the schematic a little bit in order to add some female sockets for hooking up for testing. And of course I do still have all of my clock and control and test harness to-dos that I need to complete as well. Those will be coming in future videos. Thank you, and we'll see you soon.